Okay, so for question 1 part A, we are supposed to actually have a few parts to do, and at the end of the day, we are actually supposed to actually find this integral here. Okay, so we will start for part 1. We are supposed to differentiate 2 square root x. So this should be quite simple. Basically, you just consider square root x as x to the power of half, and then you will just do the differentiation. You will actually get the answer. Okay. Then for part 2, we are supposed to actually differentiate this expression here, but however, please do not actually use this expression directly, because to actually simplify the working, you should actually know that the e and the ln will cancel each other, and basically just means that this question is about differentiating 1 over square root x plus 3. Okay, so we are supposed to differentiate this. Okay, so what is the way to do it is, I will actually consider this as the power of minus 1. Okay, and then from here, do a bit of manipulation. You actually obtain what the question actually want you to show. Okay. Then from here, we are supposed to hence use integration by parts to evaluate this particular integral. Now, because integration by parts, we will actually have to do the working in a few parts. It is actually quite difficult for you to actually write down the lower upper limit. So what I will try to do is, I will actually try to solve this particular integral by parts first, and then at the end of the day, after I get the answer, I will actually put in the lower and upper limit. So how to actually do this question is, we will actually need to actually take the hint from A part 2. Now what do I mean by take the hint? Basically what A part 2 is saying that if you integrate this particular expression here, you will actually get back this expression. So what I will do is, I will actually create this expression in this integral and call it v prime, which is the part that you actually want to integrate, and then those extra things that actually come out, you actually set it to be u, and that will be the one that you want to differentiate. So how am I going to do this part is that, take note, I actually remove the lower upper limit first. I will actually create this particular expression here. Okay. And because to actually so-called make sure that it's actually still equal, okay, this will be the expression that we will get. So the way that I will see is, this will be your v prime, this will be your u. So let u to be equals to minus 2 square root x, and the u prime will be actually equals to, and this is actually your part 1, just that there's only a negative sign issue. Okay, just a negative sign issue. And from here, your v prime is actually equals to this particular expression. Okay, which we know that v will be equals to 1 over square root x plus 3. So using integration by parts, we will have uv uv minus u prime v, okay, which is going to give you this particular expression. Okay, and how do we actually settle the extra integral that actually come out from here is that one should observe that this particular thing, if you see it as fx, then if fx is equals to square root x plus 3, f prime x is actually equals to 1 over 2 square root x, which is appearing here. So basically, this expression is actually f prime x over fx, which we know how to integrate, which is basically ln fx. Of course, there's a few little adjustment I need to do because there's a constant half that I need to have. So this will actually give you and I can actually put a bracket for this particular ln expressions because I know that square root x plus 3 will definitely be positive. Okay, so after I actually obtain this, finally I will actually evaluate the definite integral by substituting the lower upper limit inside. Okay, 4 and 0. So basically you're substituting in 4. Okay. So what we actually have will be something like this. Double check the working again. Sorry, it should be a plus, okay. So this should be a minus. And giving you the answer as this, which is the thing that's given to you in the answer key. Okay, then we go to the next part. The next part is we have to use substitution to actually find this particular expression. So how do we do this? We will actually first differentiate the substitution. Okay. The reason for us to differentiate the substitution is because we want, okay, dx dy, sorry. We want to actually so-called sub away the dx, which but in this case, you'll be substituting the dx to be minus 1 over 2y squared dy. Okay. Then of course, because this particular question have a lower upper limit, okay, which is actually x value originally, you will actually have to also change them to the y value. So when x equals to 1, y is actually half. Okay, and when x equals to square root 2, y is actually 1 over 2 square root 2. So we will be ready to do the substitution. So basically what we actually need to do is we will actually have to replace the dy dx, then I have to replace the x, then the square root inside, and of course the limit you replace based on position. So what do you mean by position? Because the corresponding value for x equals to 1 is actually y equals to half. Okay, and then the corresponding value for x equals to square root 2 is actually y 1 over 2 square root 2. Okay, never ever actually replace the lower upper limit by its numerical value. Okay, by position. So after this is done, the rest of the parts is basically just simplification. First thing first, because there's a negative sign here, what can I do is I can use the negative sign to switch the limits around so that I don't need to deal with so many negative signs. Then of course I have this thing here, which is actually going to reciprocate up to the numerator. How am I going to actually settle this expression here? Well, because we have so-called a denominator in a denominator, the usual way to actually simplify this will be you make it into one big fraction. Okay. Then from here, what you actually will do is the square root of this will be 2y, and the 2y will actually also going to be flip up. And how do we actually do this integration is that we will be using the formula in the formula list, okay, which is this one. But take note that in order to use all these formula in the formula list, all the coefficient for x, you have to make sure that they are all 1 before you apply the formula. Therefore, before you even start to apply the formula, you have to factor out the 4 because it's a square root, so it becomes a 2. Okay. And this will mean that the integration will be a sine inverse. Giving you pi over 2 minus pi over 4, which is actually answer pi over 4. Okay, which is the answer given at the back. Okay, so what about part C? Finding the following integral. Okay, so let's do part C1 first. So to do part C1, the idea actually behind this is that because there's a x squared plus 1 in the denominator, if I actually see x squared plus 1 as fx, I want to ask myself, do I actually see the f prime x, which is actually 2x? I did, because it's actually here. However, because there's an extra plus 1, so the strategy to actually do this is, for the very first step, I will split the integral. Okay, I will split the integral. Now, why is that I want to actually split the integral? Because, like the strategy just now, for this particular part here, I can create a 2x, which is a f prime x, by actually inserting a 2 and then a half outside. But the thing is, then how do I actually handle this part here? Well, I see it as a quadratic with a constant on top, which belongs to the integration that can be found in your formula list. Okay, so this is basically that particular integration. So with this known, I will be able to continue. This will be x squared plus 1, but take note, I use the bracket instead of a modulus because of the fact that this particular question, I know that x squared plus 1 is positive. If in usual cases, you will need to actually insert the modular sign. Then for this one, okay, and usually for the plus c, right, you can actually leave it to the very end. Okay, just make sure that you simplify everything nicely, and then you put the plus c at the very end of your answer. Okay, so how to do part 2? Part 2 is another questions on substitution. This is the particular question. So how to actually do this? The way you can do it is, well, if you are the one that don't like to actually deal with square root, you can actually square both sides. Okay, then you will actually have x equals to u squared plus 3, implying that the x du is actually equals to 2u, implying that. Okay, the reason why I always use a apostrophe sign is because this is technically not mathematically correct. It's just a way for you to see how to do the substitution. So we are ready to do the substitution. Okay, this is the question. Okay, so to do the substitution, okay, this one don't have lower upper limit, so I don't need to sub the lower upper limit. But basically, I just need to do is to sub away the dx, and then inside here, this one basically is u. So how about this one is, well, basically I have the x here already, so we just put it in. Okay, so what you will actually get is So how to actually do this is we actually will open up. And from here, the integration can be done. Okay, later at the end, we will put a plus c. So here will be 2u5 plus 8u cubed. So for this particular question, because there's no lower upper limit, you actually have to sub back the u. Okay. Okay. And then from here, we will actually do a bit of simplification. And we will actually obtain the answer given to you in the answer key. So for this particular question 2, okay, we are supposed to actually find the total area of the n rectangles. So how to actually do this is that we take note that all the rectangles is of base length 1 over n. And how to actually find out what is the height of each of the rectangles. So for the first rectangle, we can see that I will be substituting 0 into the equation of the curve to get the height. Hence, the area of the first rectangle is 1 over n times 2 to the power of 0. And the second rectangle with base length 1 over n, okay, the height is actually 2 to the power of 1 over n, okay, because you're substituting this inside. And then for the area of the third rectangle, you're substituting 2 to the power n inside with the base length to be 1 over n. And of course, for the last rectangle here, the base length is 1 over n, and the height is actually obtained by substituting n minus 1 over n into the equation of the curve. So basically, what you actually will have is that the area of the n rectangles will be equals to 1 over n to the power of 0 plus 1 over n to the power of 1 over n, 1 over n to the power of 2 over n, and until the very last rectangle, which is 2 to the power of n minus 1 over n. Now, if you actually pull out the 1 over n, which is a common factor, what you're actually left with is something like this. Okay, and take note that this is a GP, okay, of ratio 2 to the power 1 over n, number of terms is actually n of them, okay. Hence, applying the formula for the AP summation formula, we will actually have okay. So giving this, if you actually do the simplification, you will actually get this as the total area for the n rectangles, which is what the question actually wants you to show. So how to actually then consider the area bounded by the curve and really explain why this is this? Well, if you actually look at it, is that the area bounded by the curve x and the axis is actually here, okay, x equals to 1. You can see that the area of the n rectangles is actually less than this area on the curve. So how do you actually formulate this particular inequality is, we will say that the area of n rectangles is actually less than area on the curve, which means that 1 over n bracket 2 to the power 1 over n minus 1, it will be less than the integration of from 0 to 1 to the power x dx. Okay, so how do we actually do this? Will be that now, because a lot of times we will not be able to remember the formula itself, hence how do I actually remember what to do is, I know that I can't remember how to integrate to the power x, but I can actually know how to integrate with base e. Therefore, I purposely do something like this. Okay. Then from here, we will be able to actually have x being brought down. Okay. And this is actually similar to the integration of a constant with an x. Okay. And we all know that in order to do this integration is basically something like this. Okay. Hence, it becomes something like this. This will imply that substituting 1 inside, what you actually will have will be 2 over ln 2 minus 1 over ln 2, okay, giving you okay. So how far away am I actually from the equation? How far away am I actually away from the equation is that, okay, this is what I actually want to achieve. So basically, looking at what I actually have here, you can see that by doing some cross multiplication, take note everybody is actually positive, I will actually obtain what the question actually was, and hence my question will be done. Okay, for question 3, with this question here, we are actually given this particular two curve, and R is actually bounded by the region y-axis, the region bounded by the y-axis, both curve and y equals to 1. So basically, it will look something like this. Okay, y equals to 1. Okay, and bounded by the two curve, which means that this will be your particular area R. Okay. But before that, we will actually have to go and do part 1, which is actually using substitution, find this exact integral. So how do you actually do this? Well, again, it's basically the same old thing. Okay, and because again there is a lower upper limit, okay, sine theta is 0 implies that theta is 0. So when y equals to 1/4, sine square theta is half, imply that sine theta is 1 over square root 2, imply that theta is pi over 4. So the definite integral to solve it will be that, again, replacing, okay, this means that dy is to be substituted by sine theta cosine theta d theta. Okay, then this square root, your y is half sine square theta, below is 1 minus sine square theta. Okay, then the limit will be 0 and pi over 4 respectively by position. Okay, so with this, is basically left with the simplification. Again, all constants you can actually pull it out to actually make your life simple. Okay, so this is sine square theta. And how to integrate sine square theta? Well, we will use the double angle formula to so-called remove the power so that we can actually do the integration. Okay, and then from here, we will know that this is pi over 4 minus half, and this will be the answer. Okay. Okay, next part of the question is that we will actually need to verify first that this point is actually is the intersection of both curves. Now, because it's a verification type of questions, we can actually use this answer in our working. So what do I mean? So basically, I can do something like this. When x equals to 1 over square root 2, I go and find out what is x to the power of 4, which is actually 1 over square root 2 to the power of 4, okay, giving you 1/4. And this will mean that this point is actually on the first curve, okay. And I can also do this when x equals to 1 over square root 2. I actually sub it into this particular expression, okay, giving you half over 2. This will give you 1/4 as well. Hence, it's actually on the second curve. And once you verify that it's on the first curve, it's on the second curve, this means that is the intersection between the two curves. Okay, then after this, we'll actually need to do the exact area of the region R. Now, so actually how to find this region R, if you can actually see it, is that I'm going to use this curve here, which is the curve bounded by this first particular thing by using a x dy. Okay, x dy. So take note that the very first thing that I will do is something like this, from 0 to 1. This will give me the red color area. Okay, then after this, I will actually so-called take away the boundary, okay, the boundary between this, okay, I will shade it out for you, which is this particular orange color area here. Okay, this particular orange color area here. So this particular orange color area here, if you realize, okay, this point here is actually 1/4. So basically it's 0, 1/4. Okay, the right curve, okay, the right curve, which is this particular curve here, y1 over 4, minus the left curve, which is the have to make x the subject. Now, if you actually make x the subject, what you actually discover is that it is actually this particular expression, which should look familiar to you because it's actually the expression that you actually found, okay, from part 1. Okay, so how do we then actually do this is that, okay, let's do this on the other page. Y minus the integration of 0, 1/4 of this one minus square root y over 1 minus 2y dy. Okay, so this is the area that we want. So how to actually do this is 0. Okay, this one is the same. Okay, and this basically I really just now found already. It's actually something like this. Okay, from part 1. Okay, so from here, what we actually need to do is this is actually 4/5. Okay, minus this particular question here is 1/4 to the power of 5 over 4, then times 4 over 5, plus, okay, I will do multiply everything in. Okay, multiply everything in. Okay, so this here, how do we actually then simplify? Will be that this particular expression is actually like this. Okay, then this will means that this particular thing will be 4/5. Okay, and from here, what you actually will have is 1/5 square root 2 plus 1 over 4 square root 2 plus pi over 8 square root 2. This will actually give you And if you actually want to get the answer at the back, basically what you actually need to do is to rationalize it, giving you the answer given to you is the answer key. Okay, so this is the way to actually solve for the area. Now for the volume part, okay, for the volume part, I will actually need to erase. So for the volume part, what we actually need to do is now this arrow is actually rotated about the y-axis. So basically, if you can actually imagine the arrow again, okay, let me erase all these things to concentrate on the arrow again. So this is arrow, okay, this is arrow. Okay, this point here is actually 1/4, this point here is 1. So how do you actually then get the volume that's rotated, okay, about the y-axis? Is that first thing first, the formula that you can use is x squared dy. Okay, because this is the formula that you can use when you rotate a volume. You want to actually get a volume rotated about the y-axis. For the pi y squared dx is the one that is actually for you to actually get volume rotated about the x-axis. So for this particular case, how do we actually just need to do is that we will just need to actually find the volume as that actually is created from here, okay, which is basically pi y half dy from 0 to 1/4, okay, plus the volume that's created from here, okay, which is pi 1/4 1, okay, the x squared for this, okay, sorry, there's a mistake. This part here should be this curve here, okay, which should be y1 minus 2y dy. Then for this part here will be actually y half dy. And if you actually add them together, how to actually do this? You don't need to integrate, although this can be integrated with paper and pen. Basically, how to integrate this? You do a long division first, and then you can integrate. But because this question actually just wants you to actually correct to 3 decimal places, this one basically you just use GC to solve. You should be able to get the answer that's given to you in the answer key. Okay, for question 4a, okay, how do we actually do this is that we'll be doing by parts, but how do we actually know that this has to be done by parts is that if you recall by parts, that is these 5 letters that actually help you to remember how do you actually select for you the part that you actually want to differentiate. However, I like to see LI as Li as a subgroup and AT as another subgroup. Reason being that whenever you see an expression for integration that contains log or inverse trigo inside, you should know that if there's no other things that have been stated, you should also know that it must be done by integration by parts, because for the log and the inverse trigo, you can only differentiate them and not integrate. So for this particular expression, you can see that there's a ln there, hence I actually know it must be done by integration by parts. So this is the question, okay, so let u to be equals to this, and v prime equals to x minus 2. So u prime will be 1 over x plus 1, my v will be minus 1 over x. Okay, so doing integration by parts, we will have uv minus u prime v. And how to actually do this integration is that we see that there are linear factors in the denominator. Therefore, what we actually will do is we will actually split okay via partial fraction, and then from there you will see that the integration can be done easily, and that will be the answer. Okay, so how to then do the second part, part B, is that we have these two curves and we are supposed to find the volume generated when R, this area is rotated about the x-axis. Thinking process will be, if it's actually rotated about the x-axis, it must, the formula that you can only use is pi y squared dx. Next thing is that you must actually do an imagination, how will the figure look like when this arrow is actually rotated about the x-axis, then you actually see that this part of the curve here, which I'm going to highlight now in pink, okay, is going to be the one that actually will create the so-called outer layer of this volume. And the one that I'm actually highlighting in light blue, okay, is the one, okay, that will so-called create the inner layer, which is so-called the gap inside your figure. So how to actually then actually do this integration is that we will actually have pi, okay, we will actually use pi y squared dx, and therefore first thing first is we have to make both, okay, y the subject. Making this y the subject will be y equals to 6 minus 2x. Making this y the subject, take note, we will actually have 2 plus minus square root x plus 1. Okay, 2 square root x plus 1. So how do we then actually do this? Is that first thing first, you will realize that this point, and this point is going to be important because that will give us all the limits that we need for our integral. So for this particular point here, I think we all agree that this is 0, 6, oh sorry, this is 6, 0, sorry, 3, 0, my mistake. Okay, 3, 0. Okay. Then for this point here, if you actually use your GC to actually solve for the in this intersection, this will be 5 over 4 comma 7 over 2. I will actually skip this step because you can actually use the GC on your own to actually find this. Then for this particular point here, by this expression, we know that this point here will be minus 1 comma 2 because this point here particularly is where the square term will be actually 0, and when will it be 0 is when y equals to 2, and when your left hand side with y equals 2, it will become 0, and hence your x should take the value minus 1. So how do we actually then do this is that we will integrate from minus 1 to 5 over 4 using this particular curve here. Okay, using this particular curve here. And to use this particular curve here, you realize that this expression is y equals to 2 plus minus. Okay, take note, it's y value 2 plus minus. So if you look at this part of the curve here, do you realize that it's actually above the value y equals to 2? And therefore, you should actually take the plus square root expression. Okay, and then I'll continue to square it, then dx. Okay, then you actually will have plus the 5 over 4 to 3, the one with the line. Okay, and then you will subtract the extra, which is from minus 1 to 3. This one here, do you realize that it's actually also this curve, but however, the y value here is now below 2. Okay, and hence this part is actually the expression that will take the minus square root 1. So once it is done, take note, the question says leave your answer correct to 3 significant figures. You will just use your GC, and I think when you use your GC, this particular answer will come up, okay, on your GC itself. And with that, the question will be done. Okay, for question 5, for this one, how to actually do this question is that we are given the parametric equation. Okay, so first part, how to actually show that y is more than or equals to minus 1/4. We will just take the parametric expression for y, do the completing the square, and then because this part of the square is always positive, we will actually claim that it's actually more than or equals to minus 1/4. So part 1 will be done. So for part 2, how to actually sketch a graph, you can actually do it on your GC. Now, take note, the GC, okay, you just key in. But however, do take note that, okay, this one, because I already did just now, when you actually sketch parametric equation using your GC, please really take note that you have to check your windows, because by default, the T minimum is actually 0. And if that's the case, right, you will not be able to get the actual shape of the graph. So take note that you have to actually change the value into a negative, to cover negative value, so that the whole graph shape will actually come out. So after this, you will just sketch a graph. Take note you have to use your ruler, okay, to actually do this axis. So it's something like this, and it will actually pass through the origin. So how then we will actually get the other intersecting, other x-intercept will be, we will find the x-intercept first. So you will have to actually let y to be 0. Okay, this means that your t is actually 0 or 1. Okay, and then when t equals to 0, you sub back into your x expression, which is your t squared plus 2t. You will see that x is actually 0, which is actually origin. Okay, origin takes t equals to 0. And when you sub in 1, this will give you x equals to 3. Okay, so this is actually for t equals to 1. Then for the y-intercept, you will actually let x equals to 0. So t squared plus 2t equals to 0. This will imply that t is 0 and minus 2. Okay, so t again sub in 0 is x equals 0. When you actually sub in minus 2 into your y, which is this one, okay, it will be actually 6. So this will be done. So after this is done, what we actually need to find is that we need to find the exact area bounded from 0 to 8. So how to actually look at from 0 to 8, this is actually 8. This is the area that we actually want. So how to actually do this is that we will actually have to start with 0 to 3 y dx. And how do we actually find the area bounded by the curve when the curve is actually a parametric equation? We will start from y dx, and then later we will carry out integration by substitution. However, because the area is actually under the x-axis, please put a negative sign to it. Okay, so for this done already, how do we actually do this? This is the area. So how to actually do this is you actually just do it like your integration by substitution, because your y is actually t squared minus t. So you can sub your y to be t squared minus t. To sub dx, you just need to differentiate x. So this means that your dx is replaced by 2t plus 2 dt. Okay. The limit also have to change in terms of t, but because just now we already found what is the t value for each of the corresponding thing, okay, please, this will be the one that you actually want. Okay, so for this later, this one here, you will actually do the same thing, but for x equals to 8, you actually have to actually sub it in to the expression for x. Okay, and then you will find that this will be actually in t equals to 2 and t equals to minus 4. So which one do I actually, we know which one is it? You will sub this 2t value, t equals to 2 t equals to minus 4, into the value of y. Okay, for t equals to 2, you will actually get y equals to 2. For t equals to minus 4, you actually get t equals to 20. So basically, it's actually a higher point here. So for this particular point here that we actually are interested in, is actually t equals to 2. So let's just put it in. So the rest of the working is just basically to open this up. Okay, if you actually open this up, what you actually will get is something like that. Okay, I will skip some step. You should actually get this as the expression, because there are terms that will be actually cancelled off. Okay, then to integrate, you will actually have this. Okay. On 0, this one is the same integration. Okay, so from here, what you actually will have is half minus 1. 2 to the power of 4, it will be 8 minus 4 minus half minus 1. So this will be half plus 4 plus half. This will give you 5, which is the answer given to you in the answer key. So done with part A. For part B, we are given these two curves. Okay. Okay, for part B, we have these two curves, and we are supposed to actually get the intersection of these two curves. So basically, you should by now know that in order to get the intersection, you just do this. That means you solve both simultaneously. So you open it up, and then you actually will see that your answer for x will be actually equals to 1 and 2. And then when you actually put it in, it will be 2, 0 and 1, 3. This will be the 2 points for your intersection. Okay. Then after this, after you actually get this, how do we then actually get the volume of rotation when this arrow is rotated about the y-axis? Again, when you're actually doing volume revolution, the very first thing is to decide the formula to use. We can only use x squared dy. Next up, you have to imagine how your figure looks like when you're actually being rotated about the axis. You can see that the figure, the inside your head, the outer layer is actually formed by this part of the curve here and this part of the curve here. Okay. And then you don't need to have any subtraction step in your working because for your particular figure there's no gaps. Okay, no gaps. So how do you then actually calculate this? Well, for the first part here, we have to actually make x a subject first. So let me make x a subject first. Okay, it should look something like this. And then if you make x a subject here, it will look something like this. Okay, so how to actually do the orange color volume? You will actually have 6 minus y over 3 whole thing square dy from 3 to 6. Okay, you will take the value from the y axis. But for the blue color one, it will be from 0 to 3. Okay, 1. Okay, so which one do we actually take? We will actually take the minus square root 1. Now, why is this so? Okay, never ever just remember it's like what, positive or negative. No. How do you actually see is, you see that when you actually make x a subject, this expression is telling you that the x value is actually either more than 1, which is a 1 plus, or less than 1, which is a 1 minus. So look at the part of the curve that you're actually using to create a volume. You can see that for this part of the curve here, the x value is really less than 1, and hence I know that I have to take the expression which is with the minus square root. Which means that if let's say that I take the plus, okay, 1 plus square root 9 minus y squared over 9, which part of the curve am I actually considering? I'm actually considering this part of the curve here. Okay, so once you actually have done with these two, take note of the question. It's actually numerical values, so you can just use your GC to solve, and you will actually get the answer as shown in the answer key. Okay, we come to the last part of the question, which is actually question 6. Okay, for question 6 part 1, we are supposed to use integration by parts to actually show that this has this expression. Okay. So how to actually do this will be that we will actually use integration by parts, and this will be decided by ATE. Okay, 3 go first, then exponential. So u is sine x, u prime will be cosine x, v prime is ex, which means that v is ex. So the very first part of the working will be something like this: uv minus u prime v. Okay, u prime v. Okay, and again, how to actually solve this part here? Okay, we'll actually again have to use by parts again. U equals to cosine x, the 3 go. U prime is minus sine x, and v prime is ex. Your v is ex. So how to solve this? Becomes something like this: uv again. Okay, so ex cosine x plus u prime. Okay, it's minus, but because I'm going to use u prime v, so it's just ex sine x dx. So you can see that the integration, this integral come out again, and it seems that we have to again do integration by parts. However, usually for A-level types of exam questions, integration by parts usually you do not need to actually do more than 2 to 3 times. So if you see that things is like starting to repeat itself again, pause for a while and see, do you actually return back to the original expression? It does. So how do you actually then solve this? Is you actually just, okay, so let me do this slowly. You open everything up. Okay, ex sine x minus cosine x minus this particular integral, and because this integral and this integral is the same, you can shift it over, making it 2 times of it. Okay, and then after that, you will actually just divide it by half, hence giving you the answer. And you can actually just do the plus c at the end of your final answer. Okay, so this is done. For part 2, we are actually given this graph, and we actually have to show that the region bounded by the x-axis and the part of the curve between 0 and x equals to 5 over 2. This area. Okay, so where is actually x equals to 5 over 2? Now, if you actually calculate this using your GC, and then you go and find out what this point is, you'll realize that this point is actually pi over 2. Numerical value is actually 1.57. X equals to 5 over 2 being 2.5 should be around somewhere here. Okay, hence the problem with this question is that I have one piece of area below, one piece of area on top, and therefore in order to get this, the area should look something like this. Okay, this is the curve itself. Okay, dx, and then I have to take from 0 to pi over 2, and because this is the area below the x-axis, I have to add a minus sign to it, and then pi over 2 to 5 over 2, x over 2 square root sine x minus e pi over 4 dx. And then again, because it's correct to 3 7 figures, you can just use your GC to actually solve this. Okay. After this, we are given that the S, okay, this one I have to erase everything because it won't make you all confused. The region S is actually bounded by the curve C and the line y equals to minus e pi over 4. So the line e minus pi over 4 is somewhere here. So this is S. Then you have to write down the equation of this when it's translated e pi over 4 units in the positive y direction. This one should be simple. I hope you should all see that the equation of the curve is something like this. In the equation of the curve, something like this, because it's basically just plus e power 4 to the expression of the original curve. Then after this, you are supposed to hence show that the volume formed when S is rotated about this line, Problem with your syllabus is this, okay? Your syllabus only provide you with 2 equations for finding integration to find volume revolution. It's pi y squared dx, pi x squared dy. Pi y squared dx is for you to actually get the volume rotated about the x-axis, whereby x squared dy is for you to find the volume rotated about the y-axis. But this axis that you can see when we rotate the volume is not the x-axis or the y. So how to actually do this is we actually take the hint, because just now the hint says that please translate the curve, okay, e pi over 4 unit in the positive y direction. When you translate, it actually becomes something like this. So this is the equation ex over 2 square root sine x. So if you actually look at this, do we agree that the volume of S rotated about this line is the same as this equation rotated about the x-axis? So because of this, in order to get this volume here, the way that we solve it is pi x squared or y squared dx, which is actually ex sine x, integrate from 0 to pi, okay, because if you think about it, when you translate up, the x coordinate still remains at 0 and pi, okay, dx, okay, this will be the expression. So how to actually then, you actually get, okay, let me do this properly. So this will be the actual volume. So how do you actually calculate this actual volume? So you actually then do this, and you can see that this as integration is basically the integration that the question asks you to solve from the very first part. So you just need to throw everything in, set it to be pi, and from there you will be able to get what you actually want. E pi, sine pi is 0, cosine pi is minus 1. So 0, this is half, sine 0 is 0, cosine 0 is 1. Okay, so from here, what you actually will get is pi over 2 e pi plus 1. Okay, which is the answer given at the back of the answer key. So with this, we are done with all 6 questions.